Alright, so once again we're going to be covering the skeletal and muscular systems this week. We unfortunately were not able to meet for a lecture in person, so we'll be doing the online recordings here, and unfortunately I cannot put it all in one video, so you'll find separate videos, all with different URL links to YouTube videos covering the material. If you have any questions, feel free to let me know, but otherwise we'll go ahead and jump right in. So we'll start off with the skeletal system, looking at bones and bone tissue. So your bones have multiple functions. The most obvious functions are those that are visible through observation. Just by looking at someone, you can see how bones could support, facilitate movement, or protect the body. We can also think of bones as a storage site for calcium and phosphate, as well as an area where we produce red blood cells and white blood cells, as well as platelets. So you can think of your bones as the supportive scaffolding for your body. Without them, you'd be a limp mass of organs and skin and muscle. Your bones facilitate movement by serving as attachment sites for your muscles. Your bones protect your internal organs, like your heart is encased in your ribs, and then you have your spinal cord encased in your vertebral column, your brain encased in your skull. So when it comes to storage on a metabolic level, your bones act as reservoirs for calcium and phosphorus. You kind of store them there for a rainy day whenever the body needs them. Bones also serve as that site for red blood cell production. So again, like the white, red blood cells as well as platelets are produced here. You can kind of see here that we have a chunk of bone, and there's two different types of marrow in there. We have a red marrow, which is where the red blood cells and white blood cells would be produced, and then the yellow marrow, which is where adipose tissue or fat tissue is stored. So as you can see, bones have a lot of different functions that contribute to a functioning organism. It's not just for protection or movement. So starting off with some bone cells, you can see these are not all cells. There's cells submerged in a matrix, just like other connective tissues, like we saw with cartilage. 35% of it is organic, so collagen and proteoglycans, and then the other 65% is inorganic, and that's hydroxyapatite. And that's basically another name for mineral salts that make the bone matrix very hard. The primary mineral salt is calcium phosphate, so just think calcium when it comes to this hydroxyapatite. Without it, your bones are too flexible, and we see that in the disease rickets, where a child's legs bow outward due to the lack of calcium. The collagen makes the bones somewhat flexible, so that they can be able to withstand some force without breaking. And then proteoglycans are glycoproteins that are present in the bone matrix, and these assist in trapping water in the bone matrix. And so the key point on this slide is that bone tissue is not just bone cells, it's bone matrix and bone cells. You should be able to identify different components of bone matrix as well as the functions. And we'll talk about the different cells that are present and their functions shortly. And there are multiple different types of bone, known as primary and secondary bone. The primary is just like woven, and the initial bone that's laid out before other bone replaces it. And then that secondary bone is either compact or cancellous, spongy bone. And so we'll get to all these shortly here. So just to look at general bone anatomy first, we have different aspects of the bone that contribute to its overall function. So we have a diaphysis, and inside the diaphysis is the medullary cavity, and that's where yellow bone marrow is stored in adults. It'd be red bone marrow still if it was little kids. The epiphysis is the end, and this is where red bone marrow fills in the space of the trabecular or cancellous bone. And then we have the endosteum, that again is the inside of the diaphysis, endo meaning in, osteum meaning bone, so literally inside the bone. That's where that medullary cavity exists, inside the diaphysis, inside the endosteum. And then the periosteum is on the outside, peri meaning around or surrounding, and osteum meaning bone, so it's surrounding the bone. So it's kind of like this delicate membranous lining, and it has, it's very fibrous, has different blood vessels, nerves, lymphatic vessels. But this is the general anatomy of a bone. And we'll fill this out in lab, looking at different anatomical spots of the bone. Alright, so now we can look at different types of bone cells. So the matrix, both organic and inorganic components, these are secreted by osteoblasts. So they form the bone matrix. They're literally bone matrix builders, osteoblasts, bone producers. Blast meaning secretion or producing. They have a lot of endoplasmic reticulum and ribosomes that make a lot of proteins, and those are found in the bone matrix, like collagen and proteoglycans. Osteocytes are osteoblasts that have been trapped in the bone matrix and become hardened or mineralized. So these are your literal bone cells, and they basically just sit inside these little cavities called lacunae, and they're almost like being trapped in liquid concrete as it hardens. And so they keep the bone matrix alive. They don't just make new bone matrix. That's the osteoblasts. They maintain the current matrix once they become encased in it. So they do take in and secrete waste via special cells cell processes called canaliculi. And we'll get to that more in a little bit, but it's basically like these little processes that come off of the osteocytes that help supply the osteocyte with nutrients as well as remove wastes from it. And then osteoclasts are bone breakers. They break down the matrix by breaking down the calcium and collagen in the bone matrix. Osteoclast activity is not always a bad process, and it occurs during normal bone remodeling and repair. And we'll see there's a very fine balance between osteoclast activity as well and osteoblast activity. So the balance of these two, the homeostatic balance between osteoblast and osteoclast activity, is essential for maintaining our skeletal system. Okay, so I put this little table together just so you can kind of compare and contrast the different types of cells that we can find in bones, their functions, and then where you would find them. So this is basically everything I just said on the last slide. So now when we're looking at compact bone, this is a solid bone with no open spaces, which makes it distinct from spongy bone, which has those open spaces that we'll get to here shortly. So it's more compact. It can be found under the periosteum in the diaphysis of long bones, where it provides support and protection. So you can see here's the diaphysis of this long bone, and that's where we're going to find the compact bone. It's going to be a lot more rigid and strong than spongy bone. The microscopic structural unit of compact bone is called an osteon. That's this entire circle here. Each osteon is composed of concentric rings of calcified matrix. These are called lamellae. So it says here concentric lamellae, it's basically circular lamellae. They're all containing different osteocytes, and all those osteocytes are connected to each other via their canaliculi. Those canaliculi connect to each other as well as this central canal here in the middle of the osteon. And these are the blood vessels, lymphatic vessels, and nerve vessels that supply nutrients and stimulation for that particular osteon that serves those osteocytes. Okay, and then inside, if you look at kind of like a cross section here, this central canal has perforating canals, also known as Volkmann's canals, connecting literally all the different osteons to each other, as well as the periosteum and the inside of the bone, where the medullary cavity would be, where we would find like red or yellow bone marrow. So this bone is very much a living tissue, all right? It doesn't necessarily look like it at first glance, but you have a lot of blood vessels and nerves inside a bone, which is why it can heal very quickly. And so notice the tree trunk structures that are characteristic of compact bone. Each set of rings is a central, each set of rings with a central canal here is what we call that osteon. The darker dots that line each ring are those osteocytes that are trapped. So we can see the osteocytes here, and the osteocytes connect to each other with the canaliculi. So if we look a little closer here, the little processes that come off the cells are canaliculi. There's the little canals that connect all the little osteocytes together within the lamellae, within the osteon, all to this central canal. And again, the central canal connects to other central canals, as well as the inside of the bone, where the medullary cavity would be, and the periosteum, the outside of the bone. The system allows nutrients to be transported to the osteocytes and wastes to be removed from them. So again, can't stress this enough, your bone is very much a living tissue.